Welcome, and I'd like to introduce you to everyone on today's Hype. So you are the Vice President of Global Medical Affairs for Annexon Biosciences. You joined the company in January of this year and are responsible for partnering with and educating the medical community on Annexon's development programs through publications, congresses, and relationship building with individual thought leaders, as well as professional and patient advocacy organizations. To mention, though, prior to this time, you served as Vice President of Medical Affairs at Corcept Therapeutics, where you led efforts in support of serious diseases, including rare neuro and endocrine tumors, metabolic, oncologic, and psychiatric disorders. And prior to Corcept, Ben spent 12 years at Genentech and Roche in positions of increasing responsibility. He earned his PharmD and BS in pharmacy from the University of Sciences in Philadelphia and his BS in business administration from Arcadia University. Thank you for being here with us today. And I'm going to lead off by asking you a few questions. So
thank you.
Yeah.
And actually, I'd like to first thank KD, Katrina, yourself, and the entire Health for HD community for actually having me. So thank you so much. It's been a pleasure, and I've been on your program almost from the start today and have thoroughly enjoyed your professional panel and everything else. So excellent program. Thank you.
Thank you. It's very nice to hear. So it looks like you have your screen already and shared. So I will start off with, so we can get everyone educated. Is Annexon a new biotech company?
The short answer is no. And I also wanted, similar to Edgar, I have a disclosure slide as well. Certainly, we are going to be talking about the scientific developments, and so there will be some potential forward-looking statements, and that's my disclosure there. But to continue, Tammy, we are not a new company. We were actually founded in 2014. And before I kind of give you more details about Annexon's founding, our entire existence, our DNA, our reason for being is to revolutionize complement biology in pursuit of our mission. And our mission is to free the millions of patients who have complement-mediated diseases of the brain, the body, and the eye from their disease and help them. Now, complement, and I'm going to say a few things for your audience. I'm not sure how familiar everybody is with complement. So please bear with me, and I'll try to not get too much into the science. Complement, as the name suggests, is a complementary, in air quotes, system, part of our immune system. And what happens with the immune system is that when the body recognizes things that it considers a threat that is not self, it springs into action, and a bunch of things start to happen with the immune system to try to protect us. Now, under most circumstances, that's a good thing. That's what keeps us alive, keeps us healthy. However, what ends up happening, unfortunately, and Huntington's disease, we believe, is one of those cases, is that the body's immune system starts essentially misbehaving. It doesn't act properly. So the complement system, which is part of the immune system, is actually a cascade. And the very first protein that's in this cascade is what's on the left-hand side, C1q. And C1q sounds a bit fancy, but essentially just think about it as the initial trigger or the key for this whole cascade of proteins that work with other parts of the immune system to either do good and protect us, or if it's maladaptive and not right, to actually harm the body. This was founded in the 1960s and 1970s. However, in 2007, our scientific co-founder, the late Dr. Ben Barres, who was the chair of neurobiology at Stanford University and also a former member of the National Academy of Sciences, he delved very deep into the science of C1q in particular. And he essentially discovered and found C1q's role, its deleterious role, when it actually starts acting in the wrong way for diseases of the brain and the eye and neurodegeneration. And then in 2014, that's when Annexon was founded. Since its founding, Annexon has actually started several clinical programs in complement-mediated diseases. Again, our focus here really is to free patients from C1q-mediated diseases. We're comprised of a fantastic group of individuals. I probably should have had a picture of all of our folks, but certainly the ones who are in San Francisco. That's where I am, in the San Francisco office. I think collectively, we have hundreds and hundreds of years of experience in drug discovery, drug development, approval, and commercialization of products. And so It's a fantastic team. And again, we are all dedicated to this one particular mission, which is to help patients with complement-mediated disease. And that is really where we stand. And that's what we do every day.
Terrific. Are you working on any potential therapies?
Yes, we are. As I mentioned, our mission is a bold one. We want to transform people's lives by freeing their body, brain, and eye from complement-mediated diseases. And to do that, and I mentioned in the last slide, we have several programs. So we have several what we call flagship programs, Tammy. So these flagship programs from the very top, Guillain-Barré syndrome. I'm sure many people are familiar with Guillain-Barré. Guillain-Barré is a very serious condition. It comes with significant morbidity and mortality. And we are actually conducting the first placebo-controlled trial in Guillain-Barré syndrome in about 40 years. So there's been 40 years since there's been any kind of a trial like that. And so we have a phase 2/3 trial. It is advancing very successfully and enrolling patients, and we're very much looking forward to the completion of that trial and the next steps with regulatory authorities. Second, very important and germane to all of you, us obviously as well, is Huntington's disease. We have completed a phase 2A study in Huntington's, which I will address, I think, a little bit more in detail later based on some questions. And we're very much looking at that study and hoping to have that study inform next steps. Next is geographic atrophy. Geographic atrophy is another neurodegenerative condition of the eye. Many people may know about it. Many people have heard of age-related macular degeneration. And there's two types of it. There's a wet type where there's too much blood in the eye. And then there's what is known as dry. And geographic atrophy is an advanced form of that age-related macular degeneration. And we are essentially looking at a different compound here. You can see under the candidate column, the candidate column has ANX005. That's the compound that we've looked at for Guillain-Barré and Huntington's. In the GA, it is ANX007. And last but not least, this is something we're very excited about, is the ANX005 and 007 are antibodies or fractions of antibodies, but we also have a small molecule program. And so small molecules mean they can be taken by mouth, pill in more of a pill form, tablet or capsule form, and that would be essentially for a variety of autoimmune indications that would be using those treatments.
Okay, interesting. So is there a difference in how the therapy Annexon has for HD works versus those that target the CAG repeat?
Yes, short answer, that there is a difference. And let me, if I can forward to the next slide. Part of the scientific hypothesis of our approach is based on biology. And the biology is that there are these areas of our nervous system, and many of your folks may know about this, but if not, they're called synapses. And a synapse essentially is where two neurons, two nerve cells in the brain connect with each other and pass on signals. We must have intact synapses, functioning synapses for our nervous system to work properly. And of course, if not, that's when cognitive, behavioral, motor symptoms begin to appear. Our approach is to block, as I mentioned to you, that protein at the very top of the complement cascade, C1q, so that it can actually protect functioning synapses and therefore prevent loss and decrease disability. And I want to spend a few minutes to talk about this because this is a very important point of differentiation for us. And to do that, I'm actually going to try to pull on a bit of a metaphor. So imagine that, and I'll do this build here, imagine that our brain and our nervous system is like a tree. Now, generally, a tree would have roots, a trunk, and limbs and leaves, and it would hopefully be green and functioning well. Now, oftentimes, though, in order to keep that tree in a good shape, we essentially need to have a gardener, an arborist, who essentially comes along, snips some of the branches, some of the limbs, make sure it's getting enough sunlight, and essentially does health maintenance on that tree. C1q in normal development, that on the left side of the slide, is that gardener. Imagine it's that gardener with the pruning shears, and it's going around, and under normal conditions of the immune system, it's essentially sculpting our nervous system, the synapses. And so you can see in that little cartoon in the circle, nice signals going from one synapse, across the synapse from one to the other, and everything is fine and we're healthy. That's when that gardener the C1q protein of complement is doing its job properly. However, unfortunately, what happens is that there are individuals in whom that gardener, that C1q with the pruning shears, is not doing appropriate job, meaning it essentially goes up to the tree and essentially sees that, oh, maybe I need to essentially cut this branch or that limb, and it does things that it's not supposed to do. By doing that, it actually ends up harming the tree. And now the gardener doesn't know any better. It essentially thinks that it needs to be doing that. So that's what happens with our approach, in that we believe that C1q's role in neurodegenerative diseases is that it drives inappropriate synapse damage and loss. So you can see on the right-hand side, it says C1q, and there's this thing like with 6 legs on that synapse. And so what it ends up doing is it gets that whole immune system that I mentioned to you in the first system going. And as a result of now the immune system through C1q doing its work, it actually ends up doing neurodegeneration and damage. So that's really our understanding of the role of complement and where we are differentiated.
Okay. That really helps to have that picture and description. Explain it. Thank you for that. Has Annexon conducted any studies with ANX005 in Huntington's disease?
We have, and actually I'm going to, so ANX005 is a compound that I mentioned before we've studied in Huntington's, and it's a powerful inhibitor of that C1q, that gardener that's inappropriately cutting up the synapses and damaging the nervous system. The neurodegeneration, we believe, is mediated through that process. So Annexon005, which is administered intravenously, has actually been studied in that situation. Now, we've looked at the study, this phase 2A I mentioned to you, trial of Annexon005, and analyzed it in a few different ways. And first, I'm going to show you this one side of the slide. Now, when that C1q protein starts acting the wrong way, as I mentioned, complement is a cascade. So you start with C1q at the very beginning, and then a bunch of other things happen. And the things that happen, most of them in complement, have C's in front of them, C for complement. So one of the things we measured in our phase 2A study of an ANX005 in Huntington's disease patient was to actually look at downstream effects of C1q and complement. And as you can see in this slide, we assessed cerebrospinal fluid, and we detected that the levels of C3, which is something that you don't want to see too much of if you've done the right job by inhibiting C1q, is reduced in the patients who actually were treated with ANX005. So right off the bat, what this is telling us is that the drug is inhibiting C1q and complement activation. That's why we have less of that C3. And it actually, in these patients, you can see in that shaded region, they even continue to have less C3 even when they were off treatment. There were 28 patients in this trial, and these patients had both pre and manifest HD, and these patients received the drug for 24 weeks. So as you can see, the treatment period goes weeks 0 to 24. So this was a 24-week trial, and it was not placebo-controlled, being a 2A trial. Now, the other thing we looked at in this study of Huntington disease patients were some biomarkers. So the damage that happens to these patients' synapses can also be described as neuroinflammation. There's essentially an inflammation in the nervous system in the brain. And one marker that we have found is YKL40, that in the parentheses. Now, something that's very important, you're going to see a red line and a blue line. And what those represent is, you see on the bottom, it says high C4A or low C4A. Not everyone who has inappropriate C1q activation damaging their synapses has the same level, right? We're all different. Some people have, just like the CAG repeats, some people have more C1q activation and damage. Some people have less, but nevertheless more than healthy individuals. So what you see here, the red line represents patients who we can identify through that C4A, which is another part of complement, having way too much, very high activation of their C1q. And then the patients within the blue are the patients who more than healthy, but not as much as the people in red. And you can see, especially in those who had the high activation of their complement based on C4AC4, that we saw that reduction in the marker of neuroinflammation. So that's also encouraging. And last but not least, we actually looked at some improved function. We looked at the composite UHDRS in these patients. Now, phase 2A trials are their primary outcomes is safety and tolerability. What you see here in this last one is an exploratory analysis. So the study was not powered and was not meant to look at functional improvement, but nevertheless, we are able to look at that based on the data we have in the 28 patients. And we saw, again, in that higher C4AC4, meaning much higher than the other group, complement activation and improvement in the CUHDRS during the course of the treatment. So that really is what we have in terms of our study so far.
So is the compound administered orally?
No, the compound is administered through an intravenous infusion. And this is a form of administration, as many of where the study subject, the participant, essentially goes to the site and they have an intravenous line placed, and then they receive the infusion over several hours.
Okay. Were there any side effects in the phase 2A clinical trial?
As far as the side effects are concerned, during the study, and actually let me just go back here because I want to build this. During this particular 24-week study, the ANX005 was generally safe and well tolerated. The most common side effect that we see in these patients is what's known as an infusion-related reaction. An infusion-related reaction typically occurs generally after the first dose. And what it really involves is flushed skin, generally in the midsection, a feeling of warmth, and a skin rash that takes place. The infusion reactions were generally mild, and again, as I mentioned, they happen after one dose, the first dose. Now, the transient nature of those has been seen not only in our Huntington disease study, but we've actually studied ANX005 across 200 plus patients. And some of these patients have actually been on the ANX005 for more than a year. So we've actually have that experience as far as the safety and tolerability is concerned. We have not observed any drug-related deaths or no serious infections have been observed throughout studies that we've done. And as I mentioned, we have these 6 completed and 2 ongoing trials. So overall, we have found it to be in the study participants to be generally safe and well tolerated.
Good to hear. Are there any certain precautions that should be taken into consideration before taking this therapy?
Yes, and actually I'm going to go to this next slide very quickly. ANX005, as I mentioned at the very first slide, targets the complement pathway, and the complement pathway is part of the immune system. There is a potential for the immune response to be decreased in these patients. So therefore, to guard against this, participants in our clinical trials receive a series of vaccinations before they receive their first dose of ANX005. I can tell you that across all of our clinical studies so far, we have not seen any serious infections.
Great. Is Annexon planning to conduct any other clinical trials in HD?
Yes. Based on the learnings from the phase 2A study that I just described to you and the group a few slides ago, we are going to be initiating a phase 2/3 trial of ANX005 in HD. As I mentioned, that first study was not placebo-controlled. This study is going to be a randomized double-blind placebo-controlled study. We are going to leverage precision medicine approach for patients with elevated complement levels at baseline. As I mentioned, there are people who have much higher than normal elevations of complement and those who have higher than normal. So that helps us, that measurement of those markers is going to help us be very precise in terms of patient identification and enrollment. We are going to be looking at patients with both manifest and pre-manifest HD with CAP scores of greater than 400 and UHDRS independent scores of greater than 80. The disease progression is going to be measured by 2 different measures at this point, both the composite UHD rating scale and TFC. And we are going to be looking to confirm our observation of the drug impact based on, again, as I said, the complement levels at baseline, if they're high or low complement. And we are going to be doing a variety of assessments across these patients: motor, cognition, behavioral, functional, and quality of life. As of course, with all trials, we will also be gathering further information on the safety and tolerability of ANX005.
Will this next study be done globally?
Yes, we are going to first start with our North American sites, and then the study will then, as we get started, then I think we're going to be rolling out some of the ex-US or European sites. So yes, it will be global.
Okay. Is Annexon working with any patient groups?
We at Annexon absolutely believe working with patient groups is a critical must-have part of our success factor for our clinical development program. So in addition to Help for HD, which I'm delighted to be part of your program today, we are definitely working with a variety of patient advocacy groups. We believe the patient's voice is very important to actually inform us in terms of not only what matters most to patients, but from a study design point of view and what we need to be very mindful of. So I can tell you that even in my so far short time with Annexon, I've gotten, in addition to today, some significant learnings from the HD patient community, and so has our clinical development team. So I think, yes, very much so. And we look forward to that continuing, obviously, as we really work on the design of our protocol for the next study.
Wonderful. Thank you for taking your time and going through all that with us and explaining everything to us. Very helpful.
It's been my pleasure. And I also want to thank sincerely all of the patients and families and study staff who actually helped make our ANX005 HD01, our first study, that our 2A, possible. Without that, we would not be here today. And I also want to really thank all of your attendees. And please stay tuned as we get more information on our next study, and we will be in touch with you about patient informing and enrollment. Thank you.